I'd like to introduce you our next speaker. So, for being an MC here, I had to make sure that I know at least a few things about the speakers. And for our next speaker, it was actually very interesting trying to find something about her. And she has these amazing biographies, which are really cool, really funny, but it's hard to know what's true or what's not true. So she's definitely living in the Isle of Dogs. She's also super passionate about dogs. And the only thing that I was certain about was the fact that she likes functional programming. So she's here today to teach us more about functional programming on the client side. And yeah, please join me in welcoming Bodil Stokke.
Ooh, there go the lights. Hi, I assume you're out there somewhere. I can't see anything. Functional programming on the client side, that sounds like a lot of fun. What I really like, though, is the screen readable to you? I feel like I can barely see it here. It's going to get worse because we're going to do some programming. But what I'd like to talk a bit about first is my favorite topic in the entire world, which is cosmonaut dogs. So you might know this one. There's one particular dog. I think she's probably the most famous dog who's ever lived by now. She's in the background there. She's famous for having been the first, I like to say the first person, but I suppose legally she's not, the first animal from this planet that actually went to space. Now, the reason she is so well known, and the reason she still lives in our hearts, is that they basically sent her up there to die. They didn't provision for how to get her back. The purpose of Laika's mission was basically to see how a creature a bit like a human would survive out in outer space, by which I mean Earth orbit. So, Laika, does my clicker work? Not yet. It worked a second ago. Oh, come on. Computers. Computer's the worst. It's completely died. Okay. I'll just hit the button on the keyboard then. Laika. So, she is by far the most famous of the cosmonaut dogs. And definitely she deserves the attention because it was all a very, very sad story. And we all hope she comes back someday, but by now it's probably too late. I would like to focus more today, though, on some of the lesser-known cosmonauts from the K9 space program. Some of which were very famous in their day, but we have forgotten just about all of them now, unfortunately. Only Laika remains in our memory. Like, there was Veterok and Ugolyuk, and if there are any Russians in the audience, please correct my pronunciation. These did the longest space flight. They held the record for the longest space flight at 22 days in 1966. For a very long time, until it was finally beaten by humans in 1971. So these were solid veterans. But the dogs that are going to be the focus of my talk today are Belka and Strelka. Belka and Strelka were famous in the day. This was perhaps the great Soviet propaganda victory of the dog space program, because Belka and Strelka completed the first successful return mission. They were only in Earth orbit for a couple of hours, but they, along with an assortment of smaller animals, a couple of rabbits, some flies, was there a frog? I don't remember. There were lots of interesting little animals, but mostly the two big ones were Belka and Strelka. So they went into space, and they completed the first successful re-entry from Earth orbit. This was in 1961, as I recall. So these are some of my personal heroes, if I may say so myself. So I figured if I'm actually going to do some programming today instead of just talking about dogs, though I could do that for the entire talk if you like, just shout. I figured what better as a subject of some live programming than a game about these greatest of heroes of the space program. So I'm going to be writing a little game today featuring Belka and Strelka in their spacecraft in space. Specifically, we will be doing some programming. We will be doing some programming about pure functional programming. And that's kind of the real topic of the talk today. I want to show you these ideas that are sort of coming into their own in the client-side programming community right now that started in Elm. There's this thing called the Elm architecture. Elm is a compiled to JavaScript language, which has the feature of being a pure functional programming language. Pure means that functions in Elm, or any Elm program, is not allowed to have side effects, which means that every time you call a function in Elm with a certain input, it must return the same output for that input, and not do something while it's executing, like print to the console or start a network request or something like that. So basically, the Elm runtime is there in the background, providing mechanisms for triggering side effects, but your own code isn't allowed to do it, which makes it easier to think about what your code is doing. By looking at a particular function, you can always be sure about what it's going to do. But I'm not actually going to use Elm today. I'm going to use this other language called PureScript, which this is perhaps a bit of a matter of personal taste, but I just prefer PureScript to Elm. They look very similar. The difference is that Elm is very carefully architected to be, for one thing, easy to learn, and it's got an efficient compiler. It doesn't take very long to type check and compile your programs, and it still is able to provide very, very good support for you when you're writing code. Like, the error messages are very helpful and actually show you what you've been doing wrong. Unlike in the language that compiles down to JavaScript, which is just, yeah, you're on your own. If something goes wrong, you got an hour or two of debugging to figure out where that character you got wrong is. Whereas Elm is small in scope and easy to learn, it is so because it has made very careful decisions about what abstractions to offer to the programmer. And this is where Elm and PureScript differ. PureScript doesn't do this. It just provides you the mechanisms for building your own abstractions on top of the core language, which means it has more of a learning curve. I would say quite a bit more of a learning curve. The error messages aren't necessarily as helpful from the compiler, but on the other hand, the type system is more powerful and you're able to express more inside the type system to make even better, to make even more sure that your code is correct based on the types and validating your code based on them. So I'm not here today to make a value judgment on whether you should use Elm or PureScript. Actually, I think if there's any doubt, then you should be using Elm until you sort of run into the limitations that are built into the design of Elm. Most people never run into them. But if you do, then PureScript is there for you. So let's get programming. Oops, getting ahead of myself. So, what we are going to be doing today. This is Earth orbit. And I'm going to be putting some dogs on there. Now, first we're going to calibrate, because even I can't read this. We're going to increase the font size until you can read it, and I'm not even sure there's any way I could get that. Oh. Can you read this? In the back? No? No? I don't think I can go bigger than this. The screen is horrible, I'm so sorry. So let's see if I can actually fit any code on this. It's going to be a challenge. Okay, so first, let me walk you through my PureScript program. On top, there are imports. We are just going to ignore those because I've just added all the imports I'm going to need. The programming environment provides good support for doing these imports, so if you're worried about there being 22 lines of imports, then don't worry, it just happens automatically for you. I got some boilerplate here, basically the main loop of the program. And the types are so easy to read in this gigantic font. Center it, but then we can't see the dogs. This is going to be a problem. Well, actually, what I can do is just maximize it while I'm working. Is that a little better? Yeah. Please shout at me when I'm doing things that are confusing, or if I could, just help you out by actually moving windows so you can actually see the code, or something like that. It's not an ideal setup in this theater. So, my main function is basically just starting up the application and setting up my inputs. This is just a lot of typing. I didn't want to bore you with it. But what I'm doing here is basically setting up a keyboard input and launching my application. I should mention at this point that I'm using a framework called PuX, which is basically a port of the Elm architecture, I guess, to PureScript. So if you've been using Elm and you decide it's time to learn PureScript, then you're going to feel right at home there. If you've also been using Redux in PureScript, you should be feeling familiar inside both PuX and Elm. So this is basically just PuX being configured and setting up rendering to the screen. And we've got some hot code reloading magic going on as well with Webpack in the background. I'm going to try and show you the basics of the framework. So the idea is you have some state which defines your entire application. There's a single state value, and this defines the state of your entire application, which might seem daunting, but it actually works really well in practice. Right now, that state is empty. It says unit there. I'm going to add some state later. And the idea is that whenever something happens, like user input, then an event is triggered. I'm defining my events here. I've predefined them for you. It's basically, we got 3 events in the system. There's a no operation event, which I've called nope. There's you want to move the spacecraft up, and there's you want to move the spacecraft down, which are called up and down. So the idea is that there is a function, and this function is called fold_p, which takes the previous state, the current state of the application, and the event, and applies the event, producing a new state. And once that happens, the view gets re-rendered to reflect the current state. And so there's a view function as well, whose job it is to turn the state into HTML. And right now, that is just producing an empty div. This is a sort of a DSL inside PuX. I like this bit because this is actually based on the library iRate, which proves that the authors of PuX have very good taste, at least. So basically, this says this is a div. The bang introduces attributes on the div, and so this sets a class attribute on the div containing the string app, and this just says the div has no contents. It's empty. So the two main components of our program are the fold_p, which is like an update function for the state, which gets an event and a state, and the view function, which gets state and produces HTML for rendering. Now, let us actually get the dogs on screen. First, I'm going to define a generic object type, which is going to represent both the dogs and the obstacles, and I should probably explain where I'm going. So I want the dogs to be flying a spaceship, and the spaceship should be able to move up and down on the screen. And there are going to be obstacles coming from the other side of the screen, which the dogs have to avoid. And if they crash with an obstacle, then it's game over. So I'm going to make myself a type called object, just for any object in the game. It's going to have a CSS class, which is a string. It's going to have an X position, which is a number. It's going to have a Y position, also a number. And it's going to have an X and Y velocity, both numbers. The idea is that an object has a current position on screen, but it also has a velocity, the direction it's moving in. So that basically every frame I add the velocity to the position, and the object will move. And so when I want to move the spacecraft, the idea is that when I press the up or the down button, I add thrust, I add velocity. I increment the velocity by a little bit, causing the spacecraft to move like in a realistic physical fashion. I'm going to write a physics engine for it later and everything. So this is the basic representation of the object, which means I'm going to extend the state into, instead of being nothing at all, I'm going to have a dogs property, which is an object. Okay, and I should initialize the state. Note the compiler is now complaining that this is no longer a valid value for my initial state. I want to put some initial dogs in there. So the new dogs object, new dogs equals CSS dogs, X position, let's make it 32, Y position 192, X velocity starts at 0, and Y velocity also at 0. Okay. And now I can actually put the dogs in the state. Oops. I should move the dogs above the state. Not that it matters, just looks nicer. So initial state now, instead of being nothing, is dogs is new dogs. Okay. So now we've got the dogs object in our state, but we actually need to render it as well, which means we have to extend the view function. So instead of being empty, this div should contain, I'm going to actually make a function called render object, which generically renders anything of type object. And in this particular instance, I'm going to get the dogs out of the state and render that. It says the render object function is red. That means it doesn't exist. So render object is a function that takes an object and returns HTML event. That's a type for an HTML document. Whoops. Just like the view. And the definition for that is it takes an object, O, and it returns a div, which has a class of O.css. It also has some CSS, style to left would be the X position of the object in pixels. Top is the O position in pixels. And that div, in turn, should be empty. So the idea here is I'm representing them in the HTML tree as just divs with a class on it. And I got some CSS, which I should probably show you so you can understand what's going on here. Basically, I've started the app with the app div in which the objects are contained. with some background. That would be the Earth that you saw earlier. And then I got like a dogs class, which has the dogs as a background. I got some obstacles for different backgrounds. So basically, I can render graphics on screen by just making a div and setting a CSS class. It's quite neat. Oh, this keeps happening. I've imported style too many times. Okay. That compiles. So now, oh, the dogs. Do you see them? This is actually from some Soviet propaganda material. It's, I think it was from a postcard, actually. It's a little drawing of Belka and Strelka in their capsule, in their rocket, which didn't look anything like that, of course, but it looks fun. And they got like streamers with Russian words on them, probably about the grandeur of the Soviet Union. It says SSSR on the wings. They got a lot of mileage out of these dogs for propaganda purposes. They were very good dogs. Okay, so now I want the dogs to move. So the way I want to do that, now I need to actually deal with events coming into my fold-p function, but the fold-p function is, I don't want to put all the logic inside one function. I want to split it up a bit here. So I'm going to make a function called update dogs, which takes an event and a state, just like the fold-p function, basically. And the fold-p function deals with side effects as well. We don't want to think about that, so I'm just going to be glossing over that. Update dogs then takes an event and a state and returns a new state. So for the base case, the easiest one to implement is if nothing is happening, if I get the nope event, we just return the state unchanged. Now, if I get the up event, we get some state, and I'm just going to take the dogs out of the state here just to make things easier. That would be, the syntax is a bit funny. So basically what this is saying is make me a copy of state where the dogs property is this new thing instead. And the new thing is going to be updating the dogs property with, oh, there's so little space on this screen, with y velocity incremented by, sorry, decremented by 0.2. So that every time a frame happens when I'm pressing the up button, there's going to be events continually coming in as I hold the up button. Its upwards velocity is going to be incremented by 0.2. So a gentle amount of thrust in the upwards direction. And when we go up, the down is very easy. Basically plus 0.2 instead. So that at least compiles, and the dogs are still there. But I'm pressing the up and down keys, and nothing happens, because while I'm incrementing the velocity, I'm actually not applying it to the position of the dogs yet. So let's write the physics engine. Physics. Basically, I'm making a function called physics, which takes an object and applies velocity on its position, returning a new object with the updated position. Physics for O is O, updated with x being OX plus OVX, and likewise Y is OY plus Y. Quite simple. And I said it's quite simple now, but if it wasn't, then please interrupt me. Just basically, I think it's going to be a bit of an ask to, if I lose you, then you'll need to like get the mic and queue up for a question. So here's the thing. If you're lost, then just shout, "Explain, please," or something like that. And I'll try and elaborate on what I'm doing. Anyway, so I got a physics function. But this just works on an object, so I'm just going to make a compound function to update the physics on everything in my current state. So I take a state and return a new state. And that simply takes a state and updates that state with dogs equals physics applied to the dogs in the old state, which means I can now, this line is going to get really long, but I can break it up, update physics with just the state. This doesn't need any events. Okay. Oh, sorry. The state is what returns from update dogs, and this is right. Which means I think, oh! Well, physics were applied at least. Okay. So now they have no velocity. So I'm going to very gently press the up button. And down. And the dogs are flying. Woo! Whee! Okay. So, but I mean, this is fun, but it probably gets boring after a short minute. So let's try and actually add some obstacles. And fortunately, I got all the mechanics for them already, so this should be, wow, I'm going to probably end this talk early, aren't I? Actually, when am I finished? 18 minutes. Excellent. We'll have like 10 minutes for questions, I'm guessing. Yes, so in my state now, I just have dogs. I want to add some obstacles as well, and the obstacles are also just objects. But I'm going to have a list of them, or an array in JavaScript terminology. So an array of objects is my obstacles. So the compiler is red, which means I need to add my obstacles to my initial state. For now, I'm just going to add an empty list. Now it compiles again, and I'm going to, before I forget that I have to do this, I'm going to update my render function to render the list of obstacles as well. And there is a function for underscore, which takes a list of obstacles, or a list of anything really, and a function to render them. That's render object, just as with the dogs. So this is a shorthand for because dogs in the state is just one object. I can just call render object on it. But for this one, this is a list of objects, so I have to go via the for function. So that's basically just what that means. So now my view function is ready for the obstacles. I need to actually create some obstacles. So up there, where are my new dogs? There are my new dogs. I'm going to have a new obstacle function as well, because they can't all be exactly identical. That would just be like any number of objects on the screen that look like just the one object because they're all on top of each other and moving at the same speed. That would be very boring. So I'm going to try and randomize a little bit. New obstacle by taking an integer and returning an object. New obstacle for n, the integer. So the CSS for that would be obstacle. And so I made CSS classes O0 to O3. And I'm basically just going to have an O here and add the number. using the show function, because unlike JavaScript, PureScript won't let you add a number to a string. It's a lot of fun doing so in JavaScript, but it's not usually what you want. So PureScript forces you to actually convert the number to a string before you can add it to another string. And the less than greater than symbol here, the operator, is basically a string concatenation. And the show function, of course, takes anything actually and turns it into a string. It's like toString in JavaScript. So this would, for each n input, it would return O with the n converted to a string. Okay, so the x position for an obstacle is 512. That is just off screen, plus 256 times 2 number n. This is also a bit interesting because note I'm using an int type, not a number type, and we all know JavaScript, which is this actually compiles to, only has the one number type, which is IE 754 floating point, which is awful, but it's what we're stuck with. We have no integer type in JavaScript, but we do in PureScript, and it just basically does bitwise operations in the compiled code to coerce JavaScript numbers into behaving like integers. But just as with using numbers and strings together, PureScript doesn't allow me to use ints and numbers together, number being the base JavaScript number type. So the two-number function simply turns an int into a number. So the idea here is that for number 0, the object should start at position 512, which is just off screen from the dogs there. Obstacle 1 should start a little further off screen, obstacle 2 even a little further, and so on. So we get sort of a staggered entry of the objects. So the idea is I want to give them x velocity, so they slowly come on screen, and we have to dodge them. So y, let's make that 128 times 2 number n. So basically, the coordinates on my game board go from 0 to 512, good round numbers. So 128 will be 1/4. So the first obstacle will start at the very top, 0 times 128, and they will basically, 4 of them will fill the whole screen in the y-axis. Velocity, this is what I was talking about. I want them to have a slow x velocity towards the left, a negative x velocity. And I want them to be slightly different depending on their numbers. But I want the top one to move the fastest, so I'm going to do 4 minus n, meaning that the lowest one is going to have minus 2 exactly, minus 0.2 exactly. And the top one is going to have minus 0.8. And, oops, I want to come out there. And the y velocity is just 0. So now we have an idea of what's going to happen. Let's actually try and put them in there. So what I need to do, for one thing, so I've already updated the view function, so they should be rendering. They should actually be rendering right now, but we shouldn't be able to see them because they're off screen. But we also have to update the physics function to make sure that, physics is being applied to the thrust is being applied to the obstacles as well. And that is, I'm just going to, because this is a list, I'm going to use the map function to map the physics function over the list of obstacles. And that actually should do it. Hopefully. Did I forget something? Or does it just take a while? Nothing's happening. So let's verify I'm rendering the obstacles. Oh, right, I still have an empty list of obstacles in my initial state. I need to actually create some obstacles before they will actually start happening. And so instead of the empty list, I'm going to map new obstacle, my obstacle creating function, over a list from 0 to 3. And now I expect to see some obstacles. Hopefully. Ah! Here's an asteroid. Ooh. We should be seeing the next one soon. There we go. And so they're going to be sort of staggered entry. They're not all asteroids. The next one is more interesting. You'll see. I'm just going to carry on. Because you'll notice now that they just sort of fly past the spaceship without the dogs actually crashing into them, which is boring. There's the next one. It's very ominous. It's Hovercat. And the last one is actually an asteroid, and it's going to take forever to come on screen. Right, so let's implement some collision detection. To get there, first of all, I need to actually keep track of whether the game is over in my state. So I'm going to add a Boolean. That's simply just a flag saying true or false. Is the game over? Oh, that's like this. Okay, so now my state is wrong. I need to add game over false in my initial state, so we start out not being in game over. And just very quickly going to write a function for testing whether two objects are colliding with each other. I've got, I can show you actually. I've cheated and I've written some math functions here for testing whether bounds intersect. They are really boring to write out, so I'm not going to force you to watch that. Collided with is going to be my function for testing. Takes two objects and returns a Boolean. True or false, do they collide? And collided with takes dogs and an obstacle and calls one of those math functions, intersects, dog bounds. I'm cheating here. What I should be doing, of course, is like doing pixel-perfect collision detection. But basically, dog bounds is a function which just sort of makes a rectangle sort of around the spaceship. And the other bounds function just does the same for the obstacles. So I'm being inaccurate, but you know, I got 40 minutes. Dogs x, dogs y, and bounds, obs x, obs y. So I got a function that can test whether two things have collided. And now I want the game over logic. This one basically just examines the current state and tries to determine should we go into game over? And if we are in game over, we play the game over animation instead of just proceeding normally. But we also need to deal with proceeding normally. So the base case, I'm going to go crazy with the pattern matching now. This is not a feature of PureScript I've explained so far. But have I even used it? Oh yes, my update dogs function. I kind of glossed over that. You should have shouted explain, explain. You notice I've defined update dogs 3 times. One for each event. This is a feature of PureScript called pattern matching, where instead of just taking a variable for the event, I can actually put a specific event value in saying that if the value is nope, then this version of update dogs, this version of update dogs is the one you should be calling. And if it's up or down, you call the other 2 versions. And the compiler will actually tell you, even if you've forgotten to include an event, because it must be complete. You can't have a function that isn't defined for one particular input. So it's very helpful. It takes some getting used to there, and I'm going to like dark magic territory with the pattern matching here. I'm going to explain what I'm doing, but I'm not really going to explain the syntax. So if in my current state game over is false, and if any collided with ST dogs, ST obstacles, this is nice and readable. Basically, what I'm saying here is, looking at my current state, if we are not in game over yet, and none of the obstacles, if any of the obstacles are in collision with the dogs, then we do this function. And what this function does is simply put us in game over. So update the state with the game over flag set to true. Because, so just let's go with the rules for this. We are not in game over already, but one of the obstacles has collided with the dogs. Go into game over. Likewise, if we are not, if you are just not in game over at all, then do nothing, just return the state. Now, if we are in game over, if the state or game over inside the state value is true, then we update state with as follows. The dogs object, we update that with no x velocity. Why did I do that? It never has an x velocity. Oh, never mind. And a y velocity, which is the previous one, plus 0.4. And I set the CSS to be dogs and game over, because I transform it a little bit when we go to game over. So actually, that's the CSS. So you know the dogs.game over, I just rotated 30 degrees, sort of pointing a little bit downwards. Of course, there's no gravity up there, so why that would happen, I don't know, but that's not important. Basically, what happens now, when we go into the game over state, we start increasing the downwards velocity of the dogs, so they would sort of fall down as if they were caught by gravity. And that's just going to continue forever. I'm not going to bother restarting the game because we're probably, yeah, we've got 3 minutes left, so that'll have to do. Let's just see first. Oops. So it is compiling. I believe I've forgotten to actually put the game over function in the FODP. But once I've done that, I think the game should actually work, which means I just made it in time. And that should be game over on the current state. Okay. Should we try crashing? That worked at least. Oh, I'm inclined to keep playing now, because there's going to be an asteroid coming up right ahead. I've got to sneak between them here. And another successful space mission. Okay, that was it. That was mildly entertaining. For my last slide, this is a brief video of Belka. Just after returning, you can see the parachute from the landing capsule there, just looking awesome after completing a successful mission. To summarize, this was an example of the Elm architecture. I was doing it in PureScript with a framework called Pux. The Elm architecture in general is also useful in plain JavaScript. That would be the Redux library, which is sort of a port of the Elm architecture to just JavaScript. You might want to check out Elm, you might want to check out PureScript and Pux, you might want to just go try Redux. Highly recommend it. It just makes, it makes cleanly writing client-side web apps a lot easier to deal with. And if you got Elm or PureScript with type checking as well, it's even easier. Right, thank you so much for listening. There is a link there to the slides. If you add /game to that, you can play the game. And the up and down keys are W and S, not the arrow keys, because my machine doesn't have an up arrow key. But you can totally play it.
So I think we still have time for one question only, so please make it no pressure.
You can ask questions about Soviet space dogs as well. I'd be happy to answer them.
Perfect. Anyone? Any question? Doesn't have to be perfect. There we are.
Hello, I'm Jason. From my point of view, right now we have the best tooling in JavaScript, the best editor support, and many libraries available. So why would one want to switch to Elm or, I don't know, PureScript? Because there's such a learning curve from...
There is. Well, there is for PureScript.
Yeah. If one wants to start using a functional language right away, he has to know a bit of category theory, maybe have used Haskell before or something. Why not stick with JavaScript in the first place?
Yeah, actually, I think this is the first talk I've done in a while where I managed to not say the word monad. But yeah, so in PureScript, there is category theory, which is why I warned that there is a steep learning curve. I believe it's worth learning just for the sake of learning it, but I mean, you can get by without it just as well as proven by people actually writing programs in JavaScript. In Elm, on the other hand, the category theory is all behind the scenes. This is also true in JavaScript, incidentally, because promises, for instance, are monads. We just never call them monads because there's no reason to. If you're worried about the learning curve, then I would say Elm is just as easy an option as JavaScript, probably a lot easier to learn, actually. But probably most of us already know JavaScript, in which case I definitely recommend just exploring the paradigms rather than the new languages and the new tooling, with tools like Redux and Immutable.js, for instance, and just basically trying to write pure functional code in JavaScript, which you can absolutely do. I would also encourage you to explore the tooling for Elm and PureScript, because you mentioned that JavaScript tooling is actually really nice currently, and I happen to absolutely agree with you, though I know there's controversy. But I find that both Elm and PureScript, to some extent, have the same tooling. Like, I was actually using Webpack now, and it also, but both of them actually have additional tooling on top, especially with the type system, where it's able to do better auto-completion, it's able to give you more immediate feedback when you're programming, it's able to help you fill in the blanks. Like, it will, my Emacs setup now will add imports for me as I type, pretty much. Whereas in JavaScript, I would always have to do the imports manually. That's really nice. PureScript isn't necessarily the most mature language yet, but we're close to a 1.0 release. I think, I'm not going to speak for Elm, though. I think Elm has been very stable for a while, but breaking changes seem to occasionally still happen. So that's something to be cautious about. But even if you're not going to be writing like web apps professionally with these languages, I would encourage you to look at them. Elm is very easy to get into and very rewarding just learning Elm.
Great. Thank you.